Hello friends, it's Sujit Wag. You are watching WikiNote channel. Today in this video we are going to study about the physics MCQs which can be asked in IIT-JEE, NEET, MHT-CET exams. So today we are going to cover the topic whose name is semiconductors. So in this video I am going to cover almost 50 questions based on this. So would like to go for solving this. So in this video I would like to give the explanation of the question as well as what will be its possible answers to the particular question and why we have chosen that answer as a solution or why we have chosen that option as a solution. So first question is, if output of a logic gate is 0 if the output of a logic gate is 0 when all its input are at logic 1, that gate is either. So it is asking us ki if the two of the inputs are 1, then the output of that gate, that the output of the logic gate is 0 when all its input are at logic 1. So these are the inputs. Suppose A and B are the input for my and Y will be the output, and Y should be equal to 0. So which gate will satisfy this condition? So for that you should know about the Nand gate, XOR, NOR or OR, XOR, NOR. So they are asking about the two gates. So you should know about the truth table of these gates. So first of all I would like to go with NAND, XOR. But how to write down this? So simple way of writing this is, suppose A, B, I would like to write it in shortcut. I will not go into the detail. So A into B, so that will be my AND. A dot B will be my, and then complement, that will be my NAND. Then I would like to go with A plus B, so that will be my OR gate, and A plus B and whole complement, that will be my NOR gate. Then I would like to go with A XOR B, so this is for A XOR B, and the next is A XOR B, so A XOR B and whole complement. So you know that A into B, 1 into 1, I am just checking this condition because we will not waste our time in checking the rest of the conditions, because they have asked you when all the inputs are at logic 1, then the gate is either. So 1 into 1, so for this is AND gate, 1 into 1, the output will be always equal to 1. So just you have to take down the complement over here, so output will be 0. A plus B, so this is OR gate, so 1 plus 1 or logic gate, I would like to write this as a 1, and the complement of this I will directly write it as a 0. Then A XOR B, A XOR B, 1 plus 1 is always equals to 0, and the complement of it is always equal to 1. So you should go through the truth table of these gates. So now our condition is what we want. We want both input are at logic 1 and the output should be equal to 0. So which of the gates are satisfying this condition? This is first, this is second one, and this is third one. So this is nothing but NAND, okay, NAND and XNOR, NAND and XNOR. So NAND and XNOR. In case of XNOR, the output is 1. So first option is wrong for us. Second, NOR or OR. Then I would like to go with NOR. So where is NOR? This is NOR. So NOR output is 0. But what is the output of OR? OR output is 1. So this is not going to be option. So second option is also wrong. Then third option, XOR, NOR. So for the XOR, the output is, for the XOR output is 0, and for the NOR gate output is also 0. So it satisfies both the condition. So this should be my answer, C, that is XOR or NOR. No need to go for the last option. If you have time, you can go for that. So this is my correct answer. In case of a PN junction diode, I would like to go with the second question. So in case of a PN junction diode, at high value of reverse bias, it should be bias, the current rises sharply. The value of reverse bias is known as cutoff voltage, Zener voltage, inverse, and critical voltage. Now see, I would like to go with the reverse bias characteristics of diode. So what is important in the reverse bias characteristics? So we should have a reverse current and we should have a reverse bias voltage VRB. So they are asking us the reverse current value increases sharply. So you can see this region. So for at this point the current rises very sharply, and in case of diode there are two breakdowns occurs at this point. One is called as Zener breakdown, and the another one is, which is not mentioned here, is avalanche breakdown. So avalanche breakdown and Zener, out of Zener breakdown, Zener breakdown or Zener voltage is mentioned over here. So this voltage is called as Zener voltage. And what are the significance of this voltage? The voltage across the diode will remain constant at this point when it is operated in reverse bias condition. Cutoff voltage, this word is used when diode is used in case of cutoff voltage, this is when diode is used in forward bias condition. So in the forward bias condition, until and unless it crosses that VTH or threshold voltage or cutoff voltage, your diode doesn't get turned on. So for the forward bias characteristics, we do have forward bias, and then we do have the forward bias current over here. So this is the cutoff voltage. This is useful in forward bias characteristics, but as they have used in reverse bias condition. And for the reverse bias, the diode has the symbol in this fashion. So suppose this is my diode. So diode should be connected. This is p-type material and this is n-type material, denoted by a vertical bar, and p-type is connected this horizontal triangle. So p-type should be connected to negative terminal and n-type should be connected to positive terminal. So this should be the significance. So this is called as reverse bias. So your answer must be Zener voltage. Inverse voltage, this concept is only present in case of your diode used as a regulator. Critical voltage, no idea about this. Now answer question number 3rd. Within depletion region of PN junction diode, okay, what happens? So within depletion region, always keep in mind, I would like to go with its answer at this point. Sorry friends, I would like to go with its answer yahan pe. So in case of PN junction diode, what happens? The p-type, normally your p-type material consists of, see, this is my p-type material. So what does p-type consist of? P-type consists of majority charge carriers as holes, and n-type consists of majority charge carriers as electrons. Minority charge carriers are electrons in p-type, and in case of n-type, minority are holes. So this is n-type and this is p-type material. So what happened at the junction? So at the junction, these electrons jump from this region to this region, this region to this region, and from n side to p side, and leaving behind a hole over here. So there is formation of hole, and hole behaves like it has a positive charge, and when electron jumps from that region to this region, we will have a negative charge over here. So this will be a negative charge over here. So that was this is the question. And the current which flows over here is called as diffusion current. If you will get the question across this, the current is called as diffusion current. Now see, the diode is unbiased, so that means we haven't connected any external power supply over here. So that should be the answer. The question was within depletion region PN junction diode. So depletion region is the region in which no charge carriers are present. So neither n-type, neither electrons, neither holes. So you can see in n side you will find the positive ions and p side negative ion. P side is negative and n side is positive. So this should be your answer. Answer is B. Next, in common base amplifier, the phase difference between the input signal voltage and the output voltage is. So the question comes into the mind, common base amplifier. Now most of the student gets confused over here. So common base amplifier, I would like to show their answer over here. So common base means you should remember one technique how to remember this. So suppose this is my NPN transistor. So it has three terminals, emitter, then we do have collector, and at the bottom we do have base. Now see my dear friends, what we have to do, if suppose I am providing input to this side and taking output from this side, so always keep in mind input is in the form of voltage, output is also in the form of voltage. So input voltage is applied across emitter and base junction, and output is taken across collector and base junction. So I would like to write down over here VEB. So what is our question? In a common base amplifier, so what do you mean by common base? We will find out three configuration like this. Common base means the base terminal is common to the input and output side. The phase difference between the input signal voltage and the output voltage is always, guys, 0. Why 0? Because if I am applying input to this side, suppose the input waveform is like this, same output I would like to go, I will get here without amplification. यहाँ पे the amplification factor is also 0.98 over here, so we never get amplified output, and this is used as a buffer. So if the question, so your answer is C, that is 0, no phase difference. So what do you mean by phase difference? So phase difference means suppose my input signal is in this fashion, so I would like to write down this VI, and suppose I am getting the output in this fashion like this. So now you can see my output is amplified, but it is phase shifted by 180 degree, and this happens in case of common emitter configuration. So the question is common base, so we have to go with the answer 0. In case of common emitter, the answer would have been the B, that is pi degree. Now the last question, question 5. Carbon, silicon and germanium have 4 valence electrons each at room temperature. Which one of the following statement is more appropriate? Keep in mind, my dear friends, silicon and germanium. Silicon has an atomic number 14 while germanium has 32. So and carbon has a 6. So everyone, if you look at the configuration, so 6, if I would like to write, it can be written as 24. For 14 it will be written as 284, and for 32 it will be written as 28, then 18, and then followed by 4. So you will find the 4 valence electron in case of germanium as well as silicon, but in case of carbon the energy gap is very huge, and it is greater than 6 electron volt between the conduction band and the valence band. So that's why mostly carbon is not used. Mostly means carbon cannot be used as a semiconductor material. So what we have to do, we have to go for the option. So I would like to check the option. The number of free conduction electron is significant in C but small in. This is completely wrong. We will find some electrons in silicon as well as germanium, so we'll look for that answer. So number of free induction is negligibly small, wrong. The number of free electrons for conduction is significant in all the 3, wrong. The number of free electrons for conduction is significant only in silicon and germanium but small in carbon. Yes, that should be your answer. Thank you, guys. Hello guys, it's Sujit Wag. You are watching WikiNote channel, and welcome to the second part of the semiconductors topic, in which we are going to cover the more 5 questions. So first of all, what is the first question? What is the output of the combination of the gate shown in the figure? So the simple answer, see, this A input is coming as it is to this gate. You should be able to identify the gate. This is OR gate, and this is nothing but AND, along with this bubble. I think you must have seen this bubble. So this is going to be your NAND gate. So now if A is coming over here as it is, so there is no input over here, so A is coming as it is as an input to the OR gate. And about A and B, so I do have 2 inputs to this NAND gate. One is A and one other is B. So NAND gate output is always A dot B, so that means A multiplies with B and Vole complement, so that is going to be this bubble sign, that is bar. And what will be the output of OR gate? OR gate is nothing but the addition of, now you can see, A plus A bar dot, sorry, A dot B and bar. So this should be your output. So the option A. I will not go for the checking of the rest of the option. Now the second question, this is interesting. If the lattice constant of this semiconductor is decreased, then which of the following is correct? So they have actually shown one diagram over here which is not present here. Sorry for the inconvenience. The diagram is like this. So we do have a conduction band over here having the energy EC, and one more band called as valence band over here having the energy EVB. So this is my valence band and this is going to be my conduction band, and the diagram is energy level diagram over here. So this is energy level on y-axis. So they have asked you about the lattice constant of this semiconductor. The graph shows the lattice constant of this semiconductor is decreased, then which of the following is correct? Now keep in mind, whenever the lattice constant means it is nothing but how your crystals or the atoms of that crystal are placed, the spacing between them, atomic structure and its spacing. So the lattice constant, if it is decreases, it is directly proportional to the conduction band value and valence band value. Conduction band and valence band value will also goes on decreasing if the lattice constant of the semiconductor is decreased. So if you can see, if there will be the reduction in the size of these bands, if there will be reduction, then the increase in the energy gap will be more, because as there is, sorry for the inconvenience. So you can see, if there is decrease in the conduction band and the valence band levels, then energy gap will obviously going to be increased. So lattice constant अगर decrease हो रहा है, then your EC and EV value are going to be decreased, and simultaneously EG is going to be increased. So my answer should be C. Next, question 3. In a semiconductor, the forbidden energy gap between the valence band and the conduction band is of the order of 1 electron volt. This is a simple answer, 5 electron volt. This is present in case of insulators, 0.1 mega electron volt. So mega means it is huge. It is also possible only in case of insulators, 1 mega electron volt. This is also possible in case of insulators. So answer is only 1 electron volt, because electrons can jump from valence band into the conduction band at room temperature also. Now the question is, what is this electron volt? So 1 electron volt, you should write down this relation, 1.6 into 10 raised to minus 19 joule of energy. Next, fourth, for a common emitter amplifier, the audio signal voltage across the collector resistance. Now, how to tackle this kind of questions, because this kind of questions are also asked in NEET exam. So you can see if the difficulty level of the questions which I am covering. So some of the questions are of 1 mark, some of the questions are of 2 marks, and some of the questions are of 4 marks also. So keep in mind, don't try to judge me that I am taking a simple examples. No, these are simple as well as difficult examples which can be asked and which have already asked in the exams. So I would like to cover this 4 marks numerical. For a common emitter amplifier, the audio signal voltage across the collector resistance is 2 kilo ohm is 2 volt. So first of all, you should draw the diagram. Common emitter, in the previous video I have also explained you about the configuration. So common emitter, as your transistor has 3 configuration, one is base, 3 terminals, base, collector, and one is emitter. So what they have asked, the audio signal voltage across the collector resistance is 2 kilo ohm is 2 volt. So if I am considering a collector resistance over here, that is RC, and then followed by this is plus VCC, call this as a RC resistance, and the voltage which they have got across this resistance is 2 volt. So I am getting the output voltage of around 2 volt, and the resistance value is 2 kilo ohm. So keep in mind, draw the diagram accordingly. If the current amplification factor of the transistor is 220, so current amplification factor is nothing but your beta, and which is nothing but IC, ratio of, how to remember this, beta stands for niche, there should be the base current, IC by IB. So the current amplification factor is 220 and the base resistance is 1.5 ohm. So they are asking you about the base resistance, so this is going to be RB, and which is simple 1.5 ohm. The input signal voltage and the base currents are, so they are asking you about the input signal voltage. Now I would like to go with the diagram. So this is my input voltage and this is the output voltage which we have got across the collector resistance RC. Sorry for this mistake, I would like to draw this diagram or collector resistance in this fashion. I can take down this connection over there. Okay, so now the input signal voltage and the base current are, so they have asked you about VI and the base current. So base current is nothing but my IB which is flowing through. This is very important diagram, guys, and the current which is flowing from VCC to emitter is called as IC, collector current. So collector current is always belongs to the output side, and the IB, that is input current, is always belongs to the input side in case of common emitter amplification, common emitter configuration. Now what is common emitter? See guys, this emitter terminal is common between my input side and output side. So that's why this is called as common emitter configuration, and which is connected to ground. Okay. Now beta is given, which is equal to 220. What are the given terms that I have to look for? I have to go to the next page. Sorry guys. Okay. So due to lack of space, I'm on this page. Now see here that input signal voltage. Now what we have to see here, that in this case I have to go for calculating the input current, sorry, input voltage. So VI, so this is going to be my VI. VI is always going to be Ohm's law, that is base current is IB into base resistance is RB. So this is my going to be VI equal to IB into RB. Now what is output voltage? Output voltage formula. So this is output side, and output current flowing through the output side is IC and the resistance is RC. So this is VI and this is VO. So what do we know in case of VI? So if you look at the output side output voltage, but they haven't asked you about this, they have asked us about VI, that is input voltage is what is, and what is the input current, that is base current. So for the base current you should know about the collector current first, because with the help of this formula we can get that formula. What is output voltage? 2 volt, which is mentioned. What is output resistance? That is 2 kilo ohm. So this 2 kilo ohm will be taken here, 2 into 10 raised to 3, and this is going to be IC. So 1 will get cancelled and I get IC is equal to 1 milliampere. So now if I am getting the IC is equal to 1 milliampere, then my beta is equal to 220. So this can I get IB over from here? Yes. So IB is equal to IC divided by beta, and what is IC? 1 milliampere divided by beta is 220. So if you look at the answer, 1 into 10 raised to minus 3. So how to tackle this? 1 into 10 raised to minus 3 and 220. So I would like to go with this 2.2 multiplied with 10 raised to 2. Okay. So left shift, that is addition, 1 upon 2, so it is almost equal to 1 by 2, so that is 0.5. And if you look at this 10 raised to 2 if it goes above, so that will be 10 raised to minus 2, 10 raised to minus 3, minus 2, minus 5, and this is 0.5. okay, so this is 0.5 approximately, I am saying, into 10 raised to minus 5. So that will be my IB. So if you look at the answer, may I get anywhere the 0.5 value, 0.5? So yes, here it is. So 5 microampere, yes, that can be my solution, 5 into 10 raised to minus 6. Now if you look at this 4 option, only in option D you will find out this option as 5 microampere. So that will be my base current. But if somewhere 5 microampere would also have been given, then how to calculate the input voltage? So input voltage is very simple now. So VI is equal to, as stated earlier, VI is equal to base current multiplied by RB. So you know the value of base current now, and what is that base current? Is nothing but 5 into 10 raised to minus 6. And what is value of RB? Is it mentioned base resistance? Yes, it is mentioned 1.5 ohm. So 1.5, so almost 1.5 into 5, it's 7.5. Yes, it's 7.5 into 10 raised to minus 6. But is it validating the value? 1, 2, 3. Okay, something is missing over here. 1.5 kilo ohm and this is 7.5 volt. So according to me, this should be your answer, but it's not matching here. But the numerical value is matching. Yes, that should be your value. Now the next question in CE mode, question 5. In CE mode, the input characteristics of transistor is the variation of. Now keep in mind how to tackle with this kind of question. So they have asked you about input characteristics, and which mode? CE mode. CE stands for common emitter mode. Diagram is in front of you. Common emitter mode, as I said, emitter is common between input side and output side. The current which is flowing in the input side is called as base current, that is IB. The current which is flowing at the output side is called as IC. So we are interested in the input characteristics. So input characteristics will be always the graph of the current versus, like a diode, the current versus the voltage. And what you can see in this common emitter configuration, the input side has a base current as IB, and the input voltage is applied across the terminal base and emitter. So this is base versus emitter. And if you look at this graph, it is same as that of your forward bias characteristics of diode. So I can draw the graph in this fashion. So why no current flows till this point? So this is called as threshold voltage, and this is 0.7 volt for silicon and 0.3 volt for germanium. So guys, but the next question is IB against VB. So that will be my solution. IB is on the y-axis and VB on the x-axis. At constant, what is this? VCE. So collector to emitter voltage I have to maintain constant. So this is going to be my VCE at different values of VCE, and that should be remain constant. So that should be your answer. If you look at the second option, what is that option? The IC against VCE. So IC, you can see guys, this is the output side, current flowing to the output side, that is IC, versus the voltage VCE at constant VBE, base to emitter voltage. So if this is the question, then the question will be output characteristics of a transistor, and IE against IC. So current versus current, that is only current characteristics. Then IE against IC, that is also the current characteristics. Sorry guys, this is IB versus IC, and this is IE versus IC. So these are the current amplification factors, I would say. So this is beta ratio of IC by IB, and this is alpha for IC upon IE. So guys, I am back with the next 5 numericals. The first question is an intrinsic semiconductor. Sorry guys, some technical issues. I have to look for okay, pressure sensitive. Okay, so now the first question is that an intrinsic semiconductor at 0 Kelvin temperature behaves like, by default it will behave like insulator. So what will be its answer? So 0 Kelvin is nothing but the absolute zero temperature. You can call it as the absolute zero temperature. At room temperature, so if you look at the energy level diagram based on energy band theory of the semiconductor, so this is going to be your conduction band and this is going to be your valence band, and there is a energy gap between valence band and conduction band, and that gap is almost 1 electron volt. So just approximate figure I have taken. So at absolute zero temperature, no electron will jump from valence band into the conduction band, and that's why conduction band is completely empty in case of semiconductor at absolute zero of temperature, and that's why it is used as an insulator. That should be your answer. I will cover second question. For the given combination of gates, if the logic states of the input A, B, C are as follows. So A, B, C are 0, so 3 inputs are 0, and A, B equal to 1 and C equal to 0. Then the logic states of output D are. So first of all, you should able to identify the gates. First is OR gate. Keep in mind, my dear friends, check whether any bubble is present or not over there. So I can see a small bubble over here, and if it is not visible, make a bubble over here. So this gate is your NAND gate. So what is first case? What is input? A, B, C are 0. So A 0, A 0, B 0 and C 0. So A OR with B, and its output is always going to be 0. C is coming as it is, C is also 0. So 0 into 0, that will be output is 0, but as it is a bubble, so output is going to be 1. So for the first case, the output is going to be 1. What about the second case? So for the second case, A and B are 1 and the C input is 0. So I would like to go with second case. So for 1 1 out input for the OR gate, the output is going to be 1. This 0 for the second case is coming as it is. So 1 into 0, the output is going to be 0, but that as this is a NAND gate, the output is going to be 1. So for both case, the output is coming as 1 1, and if you look at the option, yes, I will get the option as D. So that will be my solution. So you can tackle with like this. Question number 3, the current gain alpha, okay, alpha of a transistor is 0.9, and the transistor is connected to common base configuration. Underline this. What would be the change in collector current when base current changes by 4 milliampere? Now guys, keep in mind, for this you should know the relation between some basic terms such as this is a common base configuration and the current gain alpha is given. Alpha value is 0.9. So if you look at the formula, what should be the change in collector current? So they have asked you about the change in collector current. So I will denote it by delta IC will be what when the base current changes by 4 milliampere. So that means base current is changing by 4 milliampere, that is delta IB. Now if you look at this alpha, so alpha has a relation as IC upon IE. Now this is current amplification factor in case of common base configuration which is given, and one more amplification factor, that is beta, and beta is given by the formula IC divided by IB. So this is possible in case of CE configuration, this is possible in case of common base configuration. But what they have asked us, the changes in the collector current when the base current changes by 4 milliampere. So collector current when base current changes by 4 milliampere. So actually I should able to know about the value of beta. So there must be relation between beta and alpha, and that relation is beta is equal to alpha upon 1 minus alpha. So you have to by heart this formula. What is value of alpha? So this is 0.9 divided by 1 minus 0.9. So this is 0.9 divided by 0.1, and its value comes equal to 9. So that is the value of beta. And if you look at this formula now, I know the changes in delta base current. I have to calculate the IC. So beta I know 9 into 4, so that is going to be my 36 value. So 36 milliampere is going to be your answer. Hope you have understood what I have done over here. Now question number 4. To get the output Y equal to 1 from the circuit shown, the inputs A, B, C and C must be respectively. So the what kind of output I want? Y should be equal to 1. So how to tackle this kind of question? Now you have to go with the trial and error. So I have to check every option. 0, 1, 0. So 0, 1 and then 0. So 0 or with first you should able to identify the gate. So this is OR gate, this is your AND gate. Check down whether any bubble present or not. No bubble. So 0 plus 1, the output is going to be 1. This is 0. AND gate, 1 into 0, the output is going to be 0. So first option is wrong. We want output as 1. 1, 0, 0. So next question is 1, 0, 0. So 1 OR with 0, output is going to be 1 and again 0. So 1, 0, output is again going to be 0. So second option is also not having any chances. Third is 1, 0. So 1, 0, output is 1 and third C input is now 1. So 1 into 1 AND gate, 1 into 1, output is going to be 1. So my option is going to be C. Next question number 5. In a transistor, the collector current is always less than the emitter current because, now keep in mind, always keep in mind, in case of transistor, the emitter current IE is always the addition of base current plus the collector current, and they have asked collector current is always less than the emitter current. The value of collector current is always less than the value of emitter current. Keep in mind guys that emitter current, whenever the electrons emit from emitter side, that almost 90% of the electrons gets catched by the collector, but very few electrons, almost 10% of electrons gets combined into the base region, and there is formation of a base current. So collector side is reverse bias and the emitter side is forward bias. That should be not the answer. Few electrons are lost in the base and only remaining ones reach the collector. Yes, few electrons are lost in the base and only remaining ones reach the collector. So that's why the collector current value is always less than the emitter current. Hello guys, I'm again back with the next 5 numericals. So okay, some settings. Click on this. Okay, so now first question. A transistor has a base current of 1 milliampere and emitter current of 90 milliampere. The collector current is, so this is very interesting and simple. So always keep in mind, in case of transistor, the emitter current is always the combination of base current plus collector current, and collector current is always less than the emitter current. You can see from this equation also, and they have given the emitter current as 90 and the base current as 1, and they have asked you about the value of IC. So this value of IC is always this IC is going to be 89. An alternating current can be converted into direct current. So AC can be converted into DC, and this is property of rectifier. Dynamo will convert the AC voltage into or I would say the motion, electromagnetic induced EMF, I would say, motor, mechanical motion into the electrical motion. Transformer, just step down, step ups, or the will remain is as it is the voltage. So the correct option is only the answer D. Third is, in common emitter transistor amplifier, beta, which is given, R0 is also given, that is output resistance, and internal resistance of a transistor is okay. So internal resistance is nothing but RP, or I would like to write it as a RI. the voltage amplification factor will be, so voltage amplification factor is nothing but the AV, and voltage amplification factor will be given by the formula of output voltage to the input voltage, and output voltage will be given by the formula, if you look at the common emitter transistor. Okay, so keep in mind guys, I have already drawn this diagram. So common emitter, what you have to remember, as transistor has 3 terminal, base, collector and emitter, and that common emitter, in that word keep in mind emitter is common, so that means it should be connected to ground and it should be connected to common between input side and the output side. So this is going to be my output side, and output side IC current flows to the input side, IB current flows. So voltage amplification factor, so that means your voltage is getting amplified, so that is only possible in case of common emitter configuration, which is not possible in common base or common collector, where the unit amplification factors are just 1. Okay, we'll just focus on this. Now output, always it is a ratio of output voltage to the input voltage, and it will be given by the formula the output voltage. So this is combination of IC, and here will be a one resistance called as RC. So IC into RC divided by input voltage will be the combination of one resistance called as RB resistance. So this is combination of the current flow which flows is IB. So VI is according to the Ohm's law IB into RB. Now you can see guys, you are more smart than enough. So IC by IB is going to be my beta, that is current amplification factor. RC is given, RB is also given, beta is also given. So what is RC? RC means output resistance, and which is 5000. So I would like to write down that value, 5000 divided by input is 500 ohms. So 500. So this 0 will get cancelled. You will get the value of 5 tens are, and what is beta, which is 60 into 10. So answer is 600. That should be your answer. Now question number 4, the maximum efficiency of full wave rectifier is 81.2%. Guys, you have to by heart this value, because in case of full wave rectifier you can see the 4 diodes are used. I will not go for the drawing the diagram now. Question number 5, 3 amplifier stages each with a gain of 10 are cascaded. So always keep in mind, so I do have 3 amplifiers. Suppose amplifier 1, cascading means they are connected in series. Okay, so A2, A1 and A3, and that is one after the another, and the overall gain which is asked. So guys, keep in mind, we have seen about the voltage amplification factor in the recent numerical. So voltage amplification factor is nothing but called as a gain of that amplifier, and this gain is called as voltage gain. And suppose if I am considering beta is IC by IB, though that is called as a current gain of an amplifier. So this is also important for if the question is asked in terms of this. So as they have asked you about the 3 amplifiers with a gain of 10, now they haven't mentioned this is a current gain or voltage gain, but they are cascaded and the overall gain is. So either I will go with voltage gain of first amplifier is AV1, second wala AV2, third wala will be AV3, and the total will be, when they are in cascaded, the output total overall gain will be multiplication AV1 AV2 into AV3. Guys, I have considered voltage gains over here. You can consider current gain also, and the values are like this, 10 into 10 into 10. So the option will be 1000. That should be your answer. Thank you. Again back with the next 5 numericals based on semiconductors. So first question, the diode used in the circuit shown in the figure has a constant voltage drop of 0.5 volt. So this is the diode, you can see over here, at all currents and a maximum power rating of 100 milliwatt. So the power rating, so P max is equal to, we know the formula for the power is always given by the formula voltage multiplied by current. Okay, and which is given as 100 milliwatt. So 100 milli means 100 into 10 raised to minus 3 which is given. What should be the value of resistor R, which is connected over here, connected in series with the diode for obtaining maximum current? Now see guys, you can see the battery of 1.5 volt is connected across this diode. So this diode must get forward biased if it is getting the voltage greater than 0.5 volt. So 0.5 volt is the continuous voltage drop across this diode, and they have asked you about what will be the maximum current that can flow through this circuit. So I will apply the KVL over here, and the KVL is algebraic sum of the EMFs across the closed loop and the voltage drop. Algebraic sum of the voltage drop I into R across the closed loop is always equals to 0. So this is my theory. I always use this concept. So applying KVL to the closed loop. So this is the battery of voltage 1.5 volt. So always starts with positive because this is a positive sign over here. Then across this resistance, so there will be a voltage drop. So the current which is flowing, which is unknown, is I, and the resistance R, which is also unknown for me right now at this moment, and the voltage drop across this is 0.5 volt. So as the name suggests, it is a drop, so I have to consider it as a minus, equals to 0. So that this is going to be my equation. So 0 I have denoted by point O and then dot over here, so it will not confuse you for the O. Now 1.5 minus 0.5, so it gives rise to plus 1, and this IR, so my equation will become where should I write? So this equation will become IR is equal to 1. So these are the two unknowns. I don't know about the current flowing, I don't know about the resistance which I have to calculate. Now from the given equation, the maximum power rating of this diode is V into I, which is given 100 milliwatt. So guys, here voltage drop across this diode is also given, which is 0.5 volt. So that is interesting. So drop is always 0.5 volt. So maximum power rating will be P max, maximum current will be P max divided by this voltage drop, and which is given 100 milliwatt. So the current which I can calculate over there, I is equal to this going to be P max divided by the voltage drop across the diode, and P max is 100 milliwatt. So 100 into 10 raised to minus 3 divided by the drop is 0.5 volt, which is given in the numerical. So almost 100 into 10 raised to minus 3, it will get cancelled, 102, then 5 into 10 raised to minus 1, it will come upside, so that will be plus 1 again. So 10 raised to minus 2, everything will get cancelled over here, and 1 upon 5 will only remain, and that's going to be 0.2 value. So that is the current which is flowing through the diode, maximum current. And if I put that value over here, so that value will become 0.5 100. So this is 10 raised to minus 1, 5 into 10 raised to minus 1, 10 raised to minus 2, 10 raised to minus 2 cancel, 1 upon 5, so that is nothing but 1 upon 5, so that is 0.2, which is the value which I got, I. And now for the resistance, I will put that value into this equation. So R is equal to 1 divided by 0.2, and if I am performing 1 divided by 0.2, so my answer is going to be 5 ohm. So that should be your solution, the value of this unknown resistors which I got. Now quickly going for the second, the junction diode is the following circuit requires a minimum current of 1 milliampere to be above the knee point of 0.75 of its IV characteristics curve. The voltage across the junction diode is independent of current above the knee point. If base voltage is given, then the maximum value of R, so that voltage is above knee point, will be okay. So now again applying the KVL as I did earlier, you can see a 0.7 volt of voltage drop over here. So base voltage is given, which is 4 volt. So again our same formula which I have used here earlier, I have to use this formula. So I will use that over here, VB minus the current flowing, then resistance minus the drop across this, which is 0.7 volt, is equals to 0. So this is the current loop, and VB, which is given, which is 4 volt, 4 minus whether they have considered about the current flowing, the I, yes, which is 1 milliampere, always should be equal to 1 into 10 raised to minus 3 into resistance R minus 0.7 equals to 0. So 4 minus 0.7, this is going to be 3.3, and this value, so 3.3, then this value will become positive. So this is 1 into 10 raised to minus 3 R, and if you look at this minus 3, it will come upside and the numerator place, and 3.3 kilo ohm should be your answer. Now next question, question 3. NPN transistor are preferred to PNP transistor because they have low cost, wrong, low dissipation energy, wrong, capability of handling large power, wrong, electrons having high mobility than holes, yes, this is correct. Now from where I got this value, so for this I would like to go with why this answer, I have chosen this answer. The solution is interesting. Now what do you mean by mobility? So mobility is nothing but the ratio of mobility is given by the formula drift velocity of the electrons divided by applied electric field. So please note down this formula, guys, and drift velocity is given by the formula charge multiplied by applied electric field multiplied by relaxation time multiplied by mass of that charge carrier divided by E as it is. So this E and this E will get cancelled, and this mobility is equal to charge magnitude of the charge carrier, relaxation time tau, and the mass. So mu is inversely proportional to, if you can see here, if E and T are constant, tau are constant, mu is inversely proportional to mass. So mobility of a charge carrier is inversely proportional to mass of charge carrier. And if you look at the mass of electron is 9.1 into 10 raised to minus 31 kg, while that of proton, that is hole, is 1.67 into 10 raised to minus 27 kg. It might be not visible, 10 raised to minus 27 kg. So mass of proton, so proton is quite heavier than the electron. So if the mass is more, that means mobility is less. So mobility of proton will be less as the mobility of electron. Now you can see why NPN transistors are used. In case of NPN, I do have N type. So majority charge carriers are electrons, and for PNP majority charge carriers are holes. So that's why NPNs are preferred over the PNP transistor because of high mobility. The question number 4, for a junction diode the ratio of forward current IF to the reverse current IR is, and this is given by the formula of e raised to v upon, so this is exponential constant. Actually the value formula is like this: IF is equal to IR or I naught, that is reverse saturation current, and which is given by the formula e raised to v divided by k, which is Boltzmann constant, which is dependent upon temperature, and -1. So this should be they have asked you about the ratio, so you have to by heart this formula. This should be your solution. Now the last question for you, name of PN junction which can be used as a regulator. So this is the application of a Zener diode, so that should be your solution. Tunnel diode, this is used in case of microwave devices for the tunneling effect, or you can call it as a laser devices. Gun diode again for the generation of microwaves frequency. So that is just an engineering part. Okay guys, so the next question is, if alpha and beta are the current gain in the CB and C configurations respectively of the transistor circuit, then beta minus alpha is upon alpha into beta is equal to. So first you should know about the formula. Beta is equal to alpha upon 1 minus alpha. That's going to be my formula, which we can use, or you can use the another formula also for the alpha. Okay, so for this circuit you can see either you can replace the value of alpha or replace the value of beta. So what I can do over here, either beta is equal to alpha upon 1 minus alpha or alpha is equal to beta upon 1 plus beta. Guys, you have to by heart this relation. So I would like to go with the replacing the value of beta. So as equation is beta minus alpha, so simply we will take down the equation as alpha upon 1 minus alpha minus alpha. So this is in terms of bracket for me, divided by again, as I have replaced beta, same I will replace at the denominator place alpha into beta is alpha divided by 1 minus alpha. Now you can see, if I perform a cross multiplication at the numerator place, so it will become alpha minus in bracket, so alpha multiplied by this 1 minus alpha, so this is going to be alpha minus alpha square divided by and whole term divided by this 1 minus alpha. So this is 1 minus alpha at the numerator place. What about denominator? So as this is a multiplication, simple multiplication, so this is going to be alpha square divided by 1 minus alpha. Now you can see at the numerator 1 minus alpha and this 1 minus alpha will get cancelled, and if I solve this bracket, so alpha minus alpha, this is also going to be cancelled, but at this is minus and this is minus, so this is going to be plus alpha square, and alpha square upon alpha square, this will also get cancelled and the value will become 1. So that will be my answer. Now question 2, a change of 8 milliampere in the emitter current brings a change of 7.9 milliampere in the collector current. So this is a change, and the values of alpha and beta are, what will be the value of alpha and beta? So simple, I would like to go with the formula which we have studied earlier, beta is equal to, so what is given, the emitter current is given, change in emitter current, so change in emitter current is 8 milliamps and brings the change in collector current, so this is delta IC which is given as 7.9 milliamps. So guys, if you look at the values of alpha and beta, so from this I will get the value of alpha. Formula for alpha is the collector current to the alpha, so we have to go with emitter current, so alpha upon IC upon IE, and if you solve this 8 upon 7.9, so it will be IC upon IE, so IC is 7.9 divided by 8 milliamps, and I will get the value is equal to 0.9875. So 0.9875, can you see the answer as 0.9875? No, so they have rounded off this figure to 0.99 and I am getting this in two options. So still I am not getting the answer which I was expecting, so I have to go for the finding the value of beta. I got the value of alpha which is 0.9875. So for beta I will take down the formula, beta is equal to alpha minus 1 minus alpha, so this formula we can apply over here, and I will get 0.9875 divided by this is 1 minus 0.9875, and if you do that, so you will get the answer as 79. So this should be my answer, 17. You can perform this calculation. Okay, so go on to the question number 3. The current gain of a transistor in common base mode is 0.995. So as this is a common base, keep in mind common base hai, so alpha is equal to IC upon IE, and this value is given as 0.995. If the current gain of the same transistor in common emitter mode is, so they have asked you about the beta. Common emitter mode, we have the current amplification factor or current gain as beta, and beta is equal to alpha upon 1 minus alpha. Always keep in mind guys that the value of alpha is always less than 1, so less than unity, and value of beta varies from almost equal to, you can call it as a from 1 to 200 also. Okay, so it is always greater than 1, so that will be a shortcut hint for you people. And beta is equal to alpha upon 1 minus alpha, So alpha is, which is given 0.995 divided by 1 minus 0.995. So if I perform this, I would like to, I will get the answer as 199. That's the answer which I got. So this is the solution. Question number 4. The logic circuit shown below has the input waveforms A and B as shown. Okay, A and B as shown. Okay, sorry for that, guys. I didn't get the waveforms for this question. Pick out the correct output waveform. So it is also showing me the answer as A, but sorry, I don't have those waveforms over here. So that we should have that answer. Okay, I will resume this video. Sorry for the inconvenience, guys. We don't had this diagram over here. The logic circuit shown in the figure, input waveform A and B are shown. Pick out the correct output waveform. So don't look at the answer right now at this moment. Just that is a copy paste. Input. So keep in mind how to tackle with this kind of numerical. Always keep in mind, try to take down the dotted lines like this. So you have to check down this. So keep in mind, input A is 1 at this moment. At the same time, input B is also 1 for this time cycle. So if I will like to compare, always try from input side, not go from the option side. So 1 into 1, and this is a NOT gate. As I earlier stated that you should identify the gates, and this is a NOR gate. You can see a bubble over here, this dot and this dot. So NOT 1, its output is 0, 0, 0 plus 0 is output 0, but NOR hai, that's why the output is going to be 1. So for this instant of time, this period of time, 1 into 1, the output should be the 1. So from the answer A and B and D also, it's showing the answer. So for first case I do have 3 options. Okay, I will check for the second. So for the second, the input is 0, the input A is 0, B is also 0. So 0 into 0. So if I am getting this 0 and 0, so output will be, this will be 1, this will be 1, 1 plus 1, the output will be 1 for OR gate, and for the NOR the output is 0. So I will check where do I get that output, 0, 0. So I am getting the same output in case A also, case B also, and in case B also and case C also. So 1, then again I am getting 0 and 0, which was expected for me. So in both option, again I have to go for the next. So now input is 0 for the A side and 1 for the B side. So the option is like the 0 and 1. So 0 output will be 1, complemented 1 will be 0. 1 plus 0 is going to be 0. Sorry, it's going to be 1, but as this is a NOR, so output should be 0. So where do I get the output 0? In option A as well as in option D also I am getting the 0. Okay, now I have to go for the one more option. So now this is 1 and this is 0. So A is 1 and B is 0. So if A is 1, the output is going to be 0, and for the 0 the output is going to be 1. 0 plus 1, this will be 1 for OR gate. For the NOR, the output will be 0. So the output is 0 for the next half cycle. For in the D, it's 1. So guys, the answer is going to be A. Sorry for this, but I have also verified this. So you have to tackle with this kind of technique. Okay, so I will go for this. In Boolean algebra, the 5th question, A bar dot B bar is equal to. So what is equivalent to? So simply what I would like to do, so I will consider the two inputs over here, A, B. So suppose we have considered both input as 1 1, and suppose A bar dot B bar. So A bar dot B bar. So first take down the A's complement as 0, B's complement will be 0. Now perform the A bar dot B bar. So A bar dot B bar, so 0 into 0, it's going to be again 0, and A bar dot B bar whole complement. So now A bar dot B bar and its whole complement, so that means its complement is going to be 1. So now where I do get the output as equivalent to this. So for this I have to check down A bar dot B bar. A bar dot B bar, its output is 0, so that is not going to be your option. Then A bar plus B bar. So if I would like to perform A bar plus B bar, A bar is 0 plus 0, output is again going to be 0, so it is not equivalent to this, so again cancel. A bar A dot B, so A dot B, A into B, simple multiplication, so its output is going to be 1, so it matches with the equivalent circuit. So my answer is going to be C, no need to check for D option. Next 5 questions. A Zener diode is used as, obviously it is used for the voltage regulation. For the rectification we can use a normal PN junction diode. For the modulation I'm not sure about this. And for the detection, okay, we can use a pin diode for the detection, that is in case of micro devices, pin diode. And for the modulation we can also again use pin diode as a modulator also. For the detection we will use a photodiode. This is also one of the application. So photodiode can be used for the detection. Pin diode, P intrinsic type semiconductor and N type, so that is used for modulation if the question is asked on this. So actually this is a part of engineering question, but for your syllabus we will restrict ourselves to voltage regulation. In CE, NPN transistor, the emitter current is it is always less than as emitter current is always greater than the collector current. So more than the collector current, less than the collector current, less than the base current, equal to the difference. So this is always going to be more than. Okay. Third, the temperature of germanium is decreased from room temperature to 100 Kelvin. The resistance of germanium is. So first of all, keep in mind guys, the germanium is a semiconductor material, and you should know the graph of semiconductor against the temperature, what will the effect of their resistance. So resistance in ohm and the temperature. So as temperature increases, the resistance decreases in case of semiconductor material. This is in contrast with the conductors. So for the conductors the graph is like this. So this is one more question which I am covering here, resistance. So resistance increases with the temperature in case of conductors. So for the semiconductor, now we'll focus on our question. So from room temperature, so room temperature is normally 27 degrees Celsius, so which is taken as a 300 Kelvin approximately. It's 300.15 actually. So 300 Kelvin, and decreases as it is decreasing to 100 Kelvin. So suppose here I am having 300 Kelvin temperature, and from there I am getting a 100 Kelvin temperature. So if you look at the graph, temperature is decreasing, so what will be the effect on resistance? So here the resistance value is less, while here the resistance value is higher, so resistance is going to be increased. So as the resistance is asked for the semiconductor, this is the correct answer. Question number 4. When NPN transistor is used as an amplifier, so what will be electrons move from NPN transistor, so for the NPN transistor we know that the material is going to be NPN. So N, then followed by P, and then followed by N. So N majority charge carriers are electrons. For the base there will be hole, and again for the N there will be electrons. So electrons move from emitter to base. Electrons move from base to emitter. And for the C, the option is electrons move from collector to base. No, that's wrong. Holes move from base to emitter. That is also wrong. Electrons move from emitter to base. Why? Because in case of NPN transistor, we have to connect the N type to the negative terminal and P type to the positive terminal, while this terminal should be connected, P type should be connected to negative and N type should be connected to positive. Now what you can see, N to P, so this is going to be my emitter to base junction, while this is going to be base to collector junction. So this is base to collector, this is emitter to base. So if you look at the diagram, N is connected to negative, P is connected to positive, so this connection is forward biased. So this negative will repel these electrons towards this side, towards the whole side. So electrons will move from emitter region to the base region. So that should be your correct answer. Hope I have given you the appropriate solution. Question number 5. In breakdown region, a Zener Diode be as a constant voltage source. So that should be your answer. So this is the application of Zener Diode. We'll start with the next 5 questions. So first question is, what is the number of code combination in a 4-bit byte? Okay, so keep in mind guys, this is a byte. So byte means it is combination of 8 bits, but as they have asked you about 4-bit byte. So 4-bit byte means we do have a combination, suppose 4 zeros and then again 4 zeros. So 4-bit combination, and they have given rise to 1 byte. So 1 byte is 8 bits, and if you look at the combination means 4 times 0, then again my value will be 4 times 0, 0, 0, 1. So like that I can made a different combination 0, 0, 0, 1, 0. So how many such combinations can be made? So that for that the formula is number of combination is always equal to 2 raised to n. So bits are 8 bits, so 2 raised to 8, so that's going to be 256 combinations. So answer is must be A. Question 2. In the following circuit, the current flowing through 1 kilo ohm resistance is. So guys, keep in mind this is the symbol of a Zener diode, and Zener diode is used as a voltage regulator. So how to tackle this kind of numericals? So input voltage is 10 volt battery which is connected across the 5 volt Zener diode, and Zener diode is if this is a p type material and this is n type, it is always connected in reverse bias condition. N type should be connected to positive terminal, p type should be connected to negative terminal. And you can see a series resistance of 500 over here, call it as a series resistance and call it as a load resistance, that is RL. So the total current which is flowing is I, the current which is flowing through the load resistance is IL, and the current which is flowing through the Zener diode is IZ, which is always written. So again both get added and we'll get a total current over here. And always for Zener diode the total current is the Zener diode current plus the load current IL. Now they have asked you about the current flowing through 1 kilo ohm, so that means they have asked you about IL. Always keep in mind Zener diode used as a voltage regulator, so voltage across this is always going to remain constant, and which is given over here, that is 5 volt. So Zener diode voltage across Zener diode, that will be also treated as a output voltage, because I am getting the voltage across this, so that is going to be my output voltage, and output voltage is always equal to, if you look at the output voltage, the output voltage is Vz, which is fixed, and which is equal to IL into RL. So load resistance and the current flowing through this, and current flowing through this is IL as already stated, and this is IZ. So output voltage is fixed, that is 5 volt, because this is the whatever voltage across this, and the same voltage will be present across this branch, so that will be 5 volt. Load current, which I don't know, but I know about the load resistance value, which is 1 kilo ohm. So simple answer is 5 milliampere. 1 kilo ohm will come here, and this is 10 raised to minus 3 in the 5 milliampere. Question number 3. In silicon, when phosphorus is added, now you have to look for this. So phosphorus means this is a pentavalent impurity, and pentavalent impurity means by default this is going to be n-type semiconductor. Pentavalent means excess free electron, and excess free electrons means this is going to be a negative, that is n-type semiconductor. Question number 4. Common emitter amplifier given an output of 3 volt for an input of. So I'm getting the output voltage of VO of 3 volt for an input of 0.01 volt. If beta of the transistor which is given is 100 and the input resistance Ri is 1 kilo ohm, okay, and then the collector resistance is, so they have asked me about RC, and RC is nothing but the output resistance for me. So VO upon VI, so that is going to be a voltage gain by default. So I would like to go with the formula. So voltage gain is nothing but VO upon VI, that is output voltage to the input voltage. How to write down about output voltage? So output voltage is simply written as the current flowing through the collector to the current flowing through the resistance RC divided by VI, current flowing through the input side, that is IB, to the RB. So you have to by heart this formula, and IC upon IB is going to be my beta multiplied by RC upon RB. Whether it is given RC upon RB, the input resistance is given, that is 1 kilo ohm. RC which is not given, but what they have asked us about the RC, that is collector resistance. So beta I know, RB I know, and AV, so which is given 3 upon 0.0 volt. So you can simply take down this also, its value as 3 upon 0.01 volt. So 3 divided by 1 into 10 raised to minus 2. So this will become at numerator place, and this will become 3 into 10 raised to 2, so that is 300. So 300 equals to beta times RC divided by RB, and RB's value is given as 1 kilo ohm. So this is 1 into 10 raised to 3. So just simply multiply this, 300 into 1 into 10 raised to 3 divided by beta value is given as 100. So this will get cancelled, and I will get the value of RC, and RC as 3 kilo ohm. That should be the answer. So you can go with this kind of answer. Like question number 5, the combination of the following gate produces. Okay, so simply this is just apply one logic, 1 into 1, the output is going to be 1, and this is the you can see same input is getting copied to the both of this AND gate, and the output 1 into 1. So do we have a bubble over here? I'm not sure, and I'm not getting whether I do have a bubble over there or not. So no bubble. So 1 into 1 output is 1, again 1 into 1 output is going to be 1. So it is nothing but output of AND gate. You can simply take down it as a AND gate, because 1 into 1 output is 1, 1 into 0, so output is going to be 0, then again 0 0, output is again going to be 0. So yes, this is going to be AND gate of the combination. Okay, so we'll go with the next 5 question. LED is a PN junction diode which is always forward bias. LED stands for light emitting diode, which is one of the application of a normal PN junction diode. But yes, through this PN junction it emits the light. So that light may be in the red light, green light, blue light, or depending upon the combination. Second, in NPN transistor the collector current is 10 milliampere. If 90% of the electrons emitted reach the collector, then the emitter current is, guys, emitter current is always equal to, for transistor, base current plus collector current. So if my collector current is 10 milliampere, then value of emitter current must be greater than the collector current. So if you look at the options, 9 milliampere, this is wrong. 11 milliampere, this can be a solution. 1 ampere, completely wrong. 0.1 ampere, completely wrong. So IE must be greater than the IC, and 11 milliampere, which satisfies the answer. Question number 3, the combination of NAND gates shown here under figure are equivalent to. Okay, so we do have 2 gates over here. So what will be this option? That is the question. So first of all, is equivalent to. So first directly we take down the cases. 1 into 1 So as you can see, this is the AND gate, this is also AND gate. So 1 output is 1, again 1, then 1 into 1, its output is also going to be 1. Okay. Then for the second case, again I will give the two inputs 1 into 1, so this will be 1, and same 1 is getting copied over here, so this is also the 1, sorry, this is also 1. So first option is an OR gate. So for the OR gate, if you look at the truth table of OR gate, so option is 1 plus 1 is always going to be 1, so it satisfies the first case. Okay, and for the second AND gate respectively, AND gate 1 into 1, for the AND gate also, if two of the inputs are high, output is also going to be high. So first can be an option. Second, an AND gate. So first is AND gate, yes, that's true, and second NOT gate respectively. So that is completely NOT gate cannot be possible. And AND gate, yes, first can be possible, 1 into 1 AND gate, and OR gate respectively. For the second, it can be a OR gate. Okay, that can be also a possibility, but we have to check down the option then. But answer A is correct. Question number 4. When boron is added as an impurity to silicon, the resulting material is boron. So if you look at the number of boron atomic number is 5. So this is 2, 3. So this is a kind of the trivalent impurity which we are adding, and trivalent impurity, that means it will give rise to a p type of semiconductor. So p type semiconductor, that is correct answer, not p type conductor. So this is for the confusion. Question number 5. In a common base mode of a transistor, the collector current is 5.488 and the emitter current is IE is equal to 5.60. The value of the base amplification factor is, so IC upon, so this is IE, so this is alpha. So if you look at the answer alpha, so you have to first find out the alpha, and alpha will be IC upon IE, so that will be the ratio. So IC upon IE, and if I am solving this, I will get the value as equal to 0.98. So that's alpha, which is true, less than 1. And for beta, what I have to do now, so for beta, we know the formula beta is equal to alpha upon 1 minus alpha, and if you put down these values over here, so you will get answer as 0.98 divided by 1 minus 0.98. so this is going to be 0.98 divided by 0.02, and if you solve this, you will get the answer as 49. So these are the last 5 questions which I am covering right now. It will complete our 50 questions on the topic semiconductor. So last 5 question. In common emitter configuration of a transistor, the base current IB is 2 microampere, beta is 0.9, then IC is, so simple, beta is equal to going to be IC divided by IB, and they have asked you to calculate the IC is beta times IB. So that is the common emitter amplification. So 2 into 0.9, so that's going to be 1.8 microampere. That should be your solution. Second, this is quite interesting. A reverse bias diode is, so answer A, sorry for this. But how to check down this reverse bias diode? Always keep in mind, guys, how to tackle this question. So you have to check down the voltage which is present at the P side as well as to the N side. So for the diode, this is P side and this is N side, this vertical line. So how to calculate this net voltage or effective voltage across the diode? So apply simple KVL. So this is going to be my minus 6 volt, so minus 6 volt as it is, then minus, so next one is going to be a drop across this if the current is flowing in this direction. So as we have to make a reverse bias, so we'll solve for the forward bias first and then we'll make a conclusion. So for the forward bias, current should flow in this direction, current should flow in this direction, for this also current should flow in this direction. So if the net effective voltage across the diode is positive, then we can say that that diode is forward bias. If negative, then reverse bias, because for the forward bias, P type should be connected to the positive terminal of the battery, and n type should be connected to negative terminal of battery. This is our requirement. So -6 -3, so this is minus, you have to subtract this, -3 volt. So what will be the effective? -6 plus 3, this is going to be -3 volt. So the net output voltage is net voltage across the diode is -3 volt. For the second case, 3 and this is 0, so this is going to be +3. Always keep in mind, take down the sign, +3 minus in bracket, and ground means this is going to be 0, positive 0. So 3 minus 0 is again going to be +3. So that should second, so C option. So this is 0 volt, so 0 should be positive 0, then -2 volt, so minus in bracket -2 volt, so this is going to be +2 volt. So third diode is also going to be forward bias, second diode is also going to be forward bias because net voltage is positive. And for the last, so this is 2 volt, take down the its polarity, positive, then this is +2, so minus in bracket 2 volt, so 2 volt is positive, so 2 minus 2, so this is 0 volt. So from this 4 option you can see 3 option has a positive answer and only 1 has a negative. So negative means the diode will become reverse bias, and that what they have asked. So answer is A. Question number 3, the current gain of a common base transistor circuit is 0.96. So common base means alpha, and which is given 0.96. On changing the emitter current by 10 milliampere, so alpha ka formula will be IC upon IE. On changing the emitter current by 10 milliampere, so they are changing it by 10, the change in the base current will be. So they have asked you about the change in base current. So first we'll calculate this. IC is equal to alpha times IE, so IC will be equal to 0.96 times IE, and IE is your 10 milliampere. So 10 milliampere, and you will get it as IC as 9.6 milliampere. And we know the relation IE is equal to IB plus IC. They have asked us about the changes in the base current. So base current is going to be IB. So IE minus IC, that can be my formula, is equal to IB. I know the value of IC, that is 9.6. But if you look at the IE, how to calculate the IE? So simply it's IC divided by alpha. We can also calculate the value of IE, or whether it is mentioned 10 milliampere already. So 10 milliampere minus 9.6 milliampere as IB, and if you look at the answer, I will get the answer as 0.4 milliampere. So that should be my solution. Question number 4, how many NAND gates are required to form a AND gate? So the answer is 2. How many NAND gates? And so NAND gates are used in this fashion, keep in mind. So NAND gate, its symbol is like this, so A into B, and if you cancel out this bubble, so the output is A dot B and its complement. And now if you want to remove this bubble, so I would like to use one more NAND gate, but 2 inputs will be same to the one NAND gate, and this will gives rise to the output of this gate will be A dot B, which is input over here, a complement, and whole complement. So it's going to be again A dot B. So this complement will cancel this complement, and the answer is A dot B, which is the expected NAND gate. So how many NAND gates are required? So this is 1 and this is second to gate the AND gate. Question number 5, the correct relation between alpha and beta. So this is the simplest question which they have asked. And guys, this question will be for you people. You are going to tell me the answer of this. I have repeated this number of times. Just hint, keep in mind, beta is always greater and alpha is always less. So alpha value should be less than 1, and beta value must be always greater than 1 to values between 1 to 200. So that will be the hint, and just check down the answer, which will be the answer. So that's going to be my question for you people. Hope you have liked this video. I will come up with all the topics of physics within this 10 to 12 days. Every day I would like to upload one single topic. Hope you have liked my videos. Please like, share and subscribe to my channel. As I am an Indian, we are fighting with the coronavirus, so I hope these online video tutorials will help the students for those who are preparing for IIT-JEE, NEET and MHT-CET exams. If you have any question, just paste that question in the comment section below, and if time permits, I will get back to your questions and I will try to solve the question for you people. Thank you for watching this video. Thanks for watching this video. Stay tuned for more such videos. Please like and share this video with your friends. Also refer my website wikinote.org. Follow us on our Facebook page WikiNote Foundation. The links for the same are provided in the description box below.